Okay, there we go. All right. So I said, good afternoon, everybody. So what I want to do today is I want to pick up right where we were at the end of last class. So if you remember, if you look back in the classroom, we were talking about sampling distributions last class, and I believe I was able to get to the sampling distribution of the sample proportion, and I was able to do one example. Let's see. Yeah, so I was able to do this one example talking about the proportion of people in the United States that have a bachelor's degree or higher, and that's where we ended last class. Does that ring a bell for people just a little bit? Okay, great. Got one yes. Okay. So what I want to do today, I'm going to pick up with that. I'm going to do more, a few more examples of that. And then I'm also going to do your review for your exam for you. So let me talk about that. I don't know why I'm having some trouble with my PowerPoint today. Let me just restart my PowerPoint. Give me a second. Just some technical issues to start. Okay. All right, so just a few notes. So I've posted your week 5 homework. I think I posted it yesterday. Did anybody get a chance to look at it yet? Nobody has a chance to look at it yet? That's okay. So it's 5 questions, and it's really a good way to study for the exam. So the questions you see on your homework are going to be like really close to the type of questions you're going to see on the exam. So what I highly encourage you to do, please, 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 please consider this. I encourage you either tonight or tomorrow to give homework number 5 a try, okay? And come to class on Thursday with any questions that you might have, okay? So your homework is posted. If you come with questions next class, I'll answer as many questions as you want. This homework is due next Tuesday, 11/17, and it's just, the homework is basically just designed to help you study for the exam. So I moved exam number 3 to next Tuesday. So exam number 3 is going to be just like the first 2 exams. You know, we're going to start class and we'll load up the exam in Blackboard. And if there's any questions throughout the exam, I'll answer them. I do want to stress this point though. The last couple exams, people have been submitting late, even if it's like 30 seconds late, just no more of that. Okay, so just when you do your exam, make sure it's submitted on time. If it's not submitted on time, I'm just going to give you a 0. So just please be mindful of that. And then also I'm going to complete your exam review today. So all we're going to do is do just example after example after example of stuff that's going to be on your exam. All right. Does that sound okay for everybody? I got one yes. Got a couple yeses. Okay. So the reason I want to do this is, you know, everybody gets a dropped exam. And so I really just want like everyone to knock this exam out of the park. Okay. So that, you know, you have a high 90 to 100 on this exam going into the last exam of the class. Okay. All right. So the next class, we're going to learn a new topic called confidence intervals. This will not be on the exam though. Okay. So, what I'll do in next class is I'll start the class and I'll say, okay, does anybody have any homework questions or any last minute questions on the exam? And then I'll take as many questions as you have. And then after that, I'll just start the lecture. Yep, there's only one more exam after this one. Yep, there's only 4 exams in the class. So the last exam, exam number 4, is going to be on 2 topics. It's going to be on confidence intervals that we're going to start on Thursday. And then we're going to learn something called hypothesis testing after that. And that last exam is going to be on the last day of class, which I believe is the 17th? Yeah, the 17th of December. And then we're done. And then it's winter break. Woo! Excited about that. Yes, time does fly. Yep. I know. And I don't know if you guys heard, but they canceled spring break. I don't know if I made this announcement, and we're actually going to start a week late next semester. Tora, what do you mean? Wait, what about the final? I don't understand your question. What about the final? Just a final exam. Yep, it's on the last day of class. There is no final exam. There's just a last exam. Okay, it's exam number 4. Just remember, the only thing about exam number 4 is that you can't drop it. Like I drop your lowest exam from exams 1 to 3, but I don't drop your exam number 4. Okay. All right, so if you just give me your time today, and class actually, I hope this is okay with everybody. Class probably won't last the entire till there is no extra credit for the class. No, class won't last the entire time today. I just want to get through a bunch of examples with you. That's good with me, and just get you nice and prepped for the exam. Okay. All right, any other final questions before I get started today? All right. Then let's jump right into it then. All right, so this is from last class, okay? Last class, we were talking about the sampling distribution of p hat, which is the sample proportion. Sample proportion, sorry about that, okay? And look, it's a statistic just like X bar, and this is what we're able to say. The shape of the sampling distribution of this p hat is approximately normal, provided you do this number check, okay? And we worked through one example of this last class, and don't worry, I'll do another example, 2 examples of this for you, so you'll have it down. All right, and then this is what we said. The mean of this normal distribution, we called mu sub p hat. It's just equal to whatever the population proportion is. And the standard deviation we denote as sigma p hat. It's just equal to this crazy formula here, okay? The square root of p times 1 minus p over n, all right? So this is nothing new here. This is what we talked about last class. So is everybody ready to go do another example of this? Yep, I got a bunch of yeses. All right, let's do it. I'm just stretching here in the background. You guys can't see me, but I'm just stretching. As a little bit of a sidebar, do you know what is a bad idea to do before you have to teach a class? Is have a big lunch. Because do you know what happens at, yep. Do you know what happens after you have a big lunch?
A food coma.
Yeah, I'm in a food coma, yes. So I'm drinking my Diet Coke to wake me up. Slapping myself in the face here. Okay. But I was hungry, I couldn't help it. All right, so here's the problem. According to the most recent General Social Survey, so the General Social Survey is a real survey done by the federal government. It asks a variety of questions, okay? It's done almost every year. They ask questions like, the only reason I know this is I was selected for it a few years ago. Things like, how much money do you make? How many people live in your house? How many miles do you drive to work each day? And then they ask like weird questions too, like how much time do you spend getting ready for your day every day? Like just weird stuff. All right, but anyways, they ask a question about tattoos on there. So according to the General Social Survey, 21% of adults have at least one tattoo, okay? So this right here, this is my value of P, the population proportion, okay? I'm just curious, what do people think of that number? High, low?
Low? 21% is not too bad.
So the reason it seems low, and this is interesting, is if you break the number out by generation, like People of your generation, I guess maybe I'm on the cusp of your guys' generation, but many of you in the class, your generation, it's much more socially acceptable to get a tattoo nowadays. So if you look at people who are like 21 to 35 now, like the percentage of them that have a tattoo is almost 40%. So this is low because it's adults of all age, regardless of, you know, just if they're 21 or if they're 75, okay? All right, so then it goes on to say, suppose a random sample of 400 adults is taken and the proportion with at least one tattoo is recorded. So this 400 here, this is your sample size. They're giving you the N, okay? So the first question says, describe the sampling distribution of p hat, the sample proportion of adults who have at least one tattoo. All right, so I'm just gonna formally define what exactly p hat here is. It's the proportion of adults in a sample of 400 who have at least one tattoo. All right, and when I say describe the sampling distribution, what I'm asking you to do is this stuff right here. I'm asking you to verify that it's normally distributed, say what the mean and what the standard deviation is. All right, so the first thing you're gonna have to do for these type of problems is you're gonna have to do a number check. And all this number check is this right here. All right, you need to take and check that n times p times 1 minus p is greater than or equal to 10. Well, and my n is 400, and my p is given right here. So it's 0.21 times 1 minus 0.21. And I just have to see that that's greater than or equal to 10. So just grab your trusty calculator that never lets you down. So you're going to take 400, you're going to multiply it by 0.21, and then you're going to multiply that by 1 minus 0.21. And when you plug this in your calculator, you should get, I hope at least a couple people are following along with me, just to check my math. Is this number right? Anybody else get this? Okay, great. So it's 66.36. Which is greater than or equal to 10. So my number thing checks out, okay? My number check checks out. So this is what we can say. Thus, the sampling distribution of p hat is normally distributed with mean, which we call mu sub p hat, so the average of the p hats. And that average is just equal to whatever the population proportion is. Excuse me. Excuse me. And so what is the value of p here? Thank you very much. Appreciate the bless you in there. Thank you. So the mean mu sub p hat is just whatever this value is, 0.21. Now the standard deviation is a little bit harder, okay? It's just the square root of p times 1 minus p all over n. So it's the square root of p, which is 0.21, times 1 minus that, 1 minus 0.21, all over the 400 people that we sampled. So look, I really encourage you to take out your calculator and make sure you do this right, because I've been doing this a while. I don't know how many years, 12 years, I guess, 12, 13 years, something like that. And for as long as I've been doing this, students who miss these problems, it's because they just make a little small error in your calculator, okay? So it's second function square root, 0.21 times 1 minus 0.21 times, and then in parentheses, excuse me, 1 minus 0.21. Close the parentheses, divide by 400. How many people got this? If you're following along. Awesome, awesome, great. Does anybody remember how many decimal places I said you should go out with this? Yeah, you have to go out 4 with this, okay? So on the exam, make sure you go out 4, okay? So it's 0.0204 when I round it. Okay. This, once you have this, the rest of it kind of just like falls into place, all right? So next question. In a random sample of 400 adults, what is the probability that less than 20% have at least one tattoo? So it's the probability that your p hat is less than 0.20. So you don't have to do this. I'm just going to do it on all the problems we do today. But what do I always do that helps me figure this out? Yep. Yep. So what you're drawing here is you're drawing the distribution of p hat. And I know it's a bell curve. It's centered at the mean, 0.21. And I want to be less than 0.20. So I'm going to shade to the left. All right. You can do this by hand if you want, okay? But what's the easier way to do this? And we're going to do every single problem this way today, okay? With your calculator. Yep. So the option is Normalcdf. And then there are 4 things you need to put into it. You need to put in the lower value. And since this is a left-tailed test, what lower value do I put in? Yep. And then you go up, your upper value is next, the upper area you're looking at, which is this 0.20, because that's where the area you're looking for. Then you're going to put in the mean, excuse me, which is mu sub p hat, which is this right here, comma, and then your standard deviation, sigma p hat. That's why we found it in the previous example right here. I'll do this in the TI-83. So second function distribution, Normalcdf, -9999, comma 0.20, comma 0.21, comma 0.0204. Can someone help me out? How many people got this? Yeah. And when I round this to 4 decimal places, it's going to be 0.3120 when I do that. So what do you think? Not too bad? Seeing a second example? Think you could do one of these on the exam? Maybe. We're gonna do a couple more. You don't have to stress, okay? Also, just so to put everyone's mind at ease, on the exam, I build in a tolerance for the question. So like if you round incorrectly, okay, or maybe you went out 5 decimal places instead of 3, like I'll accept answers from everything from like 0.3110 to 0.3130. Like I build in a wide range to accept answers, okay? All right, let's, is everybody okay if I move on? Anybody need me to stay here? Bueller, everybody's good? Okay. All right, let me ask a follow-up question to this then. This is weird. Next part of this says, in a random sample of 400 adults, what is the probability that more than 96 of the 400 have at least one tattoo? Okay, do you notice the subtle difference here? Here I say, you know, I give you the percentage. Here I just give you a number. Does anybody have a suggestion on how to deal with that?
Make it into a percentage.
Yeah, how do I do that? So change the 96 into, yep, a p hat. So it would be, remember, p hat is x divided by n, so it's the 96 people, thank you, Tora, who have at least one tattoo, divided by 400. So you get 0.24. So the question now is, what's the probability of more than 24%, basically? So it's the probability that my p hat is greater than 0.24. So sketch it. Centered at 0.21. I want to be greater than 0.24. And I'm going to shade to the right here. So normal CDF. In this case, what's my lower? What am I starting at? Yep, 0.24. Yep, it's where it's this value. And my upper, because it's a tail to the right, yep, is 99999. And then that 0.21 goes in for the mean. And the standard deviation, this 0.0204 is what we found here. So let's grab the trusty calculator. Second function distribution, normal CDF, 0.24, comma 99999, comma 0.21, comma 0.0204. And how many people got this? Okay, 0.0707. And that's it. Any questions on this one before I do another one? Okay. You know, sometimes I just don't, I don't know if you guys agree, but like the hard part is not like the calculator. It's just like, when am I dealing with the percentage? When am I dealing with the mean? Like, what's my lower? What's my upper? Like, I think that's the hardest part with this. Would you guys agree? And so this is why this, yeah, go on ahead, Dulesky. You can turn your mic on or type it. Doesn't matter. So for the square root question, this part right here, Yeah, so a TI-83, sure. So you go second function square root like this. You go 0.21 times, and then in parentheses, 1 minus 0.21. Close that set of parentheses. Divide by 1,000 or 400. Oops, 400. And then what you have to do you notice on the TI-83 it started with a set of parentheses there? You just have to close that. And that's how you do it. I would bet that you did not close the final parentheses. That's what I would bet you didn't do. That would be my guess. Yeah. All right, Leonardo, then can you show us a strategy to get all that information? What do you mean by that, Leonardo? You can turn on your mic if it helps.
Sorry, I kind of have food in my mouth. That's why I didn't want to talk.
That's fine. That's fine.
Like to get the 4 things to plug into the calculator.
Like the strategy for doing that?
Mm-hmm.
It is always the lower than the upper value. And like the curve tells you this, okay? So like if it's a curve all the way to the left, the lower is always 0.99999. And then you go up to the value that you're interested in, which is 0.20. And then it's always the mean, and it's always the standard deviation. Like as you go from step to step in the problem, these two things don't change. Like notice how the 0.21 and the 0.024 is the same in each part.
Yeah, it's just the upper and lower.
The upper and lower is the only thing that changes. And you know what I'm going to do one more example of this, okay? And in this last example, I'll do one of each, okay? So that you can see how to do this. Sound good?
Yeah.
All right, let's do one last example of this. So this is an interesting statistic that is not made up, by the way, okay? So according to the Bureau of Labor Statistics, blank percent, I'll fill that in a second, of working adults work more than one job. That's okay. Don't have to apologize for being late. It's no big deal. Going to the dentist is important. I actually braved going to the dentist in the time of COVID a couple of months ago, so I got to get those teeth cleaned. I get it. All right, I'm just curious. What percentage in the chat, if you guys want to guess, what percentage of people, of working adults, do you think work more than one job? 60? Okay. I don't know what that is. The 440? Okay.
I don't know why my computer just did that. I meant to just put 34 and it just typed in everything else.
That's okay. So what's really interesting, like watching this, is so they don't discriminate by age group with this following statistic. Like for example, gosh, when I was in college, I had 2 part-time jobs. Okay, I worked at Barnes and Noble, and then I worked at a hardwood floor supplier. So I had 2 jobs. But like, you know, as I got older, I should take that back. I don't know if I should say this on the recording or not, but like, you know, I still have more than one job. You know, it's just something that I like, you know, I enjoy working. But like my wife only has 1 full-time job. So of all the working adults in the United States, it's actually only 5% of working adults work more than one job, okay? I know that's surprising and it seems incredibly low, but that's just what it is. I know I was shocked with this too. So here's the problem. Suppose a sample of 350 working adults is taken. And the proportion who work more than one job is recorded. Okay, so work more than one job is recorded. All right, so let's just give some information here, like what you're given here, okay? What is the sample size? Like how many people did we talk to for this? Okay. In this value here, this 5%, that's the population proportion. We're gonna take that as given. Okay, so you're given two things. You're given N and you're given P. Okay, that's it for all these problems. Here's the first question. Okay, let's describe the sampling distribution of P hat. All right, and so what exactly is P hat, just so we're clear? P hat's going to be the sample proportion of 350 adults who work more than a single job. Okay, what's the first thing you have to do to describe the sampling distribution? It was some type of number. Yeah, you got to do this number check, okay? Just gotta make sure that the following thing checks out. N times P times 1 minus P has to be greater than or equal to 10. Well, look, here's your N, here's your P. So it's 350 times 0.05 times 1 minus 0.05. So grab your trusty calculator. So 350 times 0.05 times 1 minus 0.05. How many people get this number if you're following along with me? Okay, good, good. So it's 16.625. So does the number thing check out? Is 16.625 greater than or equal to 10? Does it check out? Yeah, totally, totally. So we're good. So this is what we can say. Thus, the sampling distribution of P hat is normally distributed with, so it's just, you just got to do those two things. Mean, which is mu sub P hat, that's equal to P, the population proportion right here, 0.05. And then the standard deviation, you just got to go through that formula. So the square root of P times 1 minus P all over N. Square root of 0.05 times 1 minus 0.05 all over 350. So like grab that trusty calculator, okay? And like just work it and make sure you get the same thing I get. So square root 0.05 times 1 minus 0.05 divide by 350. And then what's the most important thing you got to do here? If you have a TI-83? Yeah, close the parentheses. Yep. How many people got that number right there? Anybody get it? We got one person did, 2. And then I know I'm a broken record. How many decimal places do you need to go out for? Yep, you gotta go out 4. So 0.0116, okay? All right, so all I'm gonna do now is I'm just gonna ask you some probability questions from this, okay? Is everybody okay if I move on, or does anybody need me to stay on this slide? Yep. Also, I'm really sorry I have a squeaky chair. You guys hear it every time, right? Yeah, maybe for Christmas or holidays, I'll get a new one. I don't know. Yes, this is the last major topic that's going to be on your exam. Yep. So what's going to happen is we're going to go right to break, and then after break, I'm going to spend all the time after break going over the topics on the test. Okay. Don't worry, Leonardo. I got you.
Very nice.
Oh my God. I regret engaging with you right now. Okay. Everybody okay if I move on? Okay.
Wait, Professor, you know where that's from, right?
Yes, I do. Yes, I do. Okay. I pay attention to what's going on in the world just like everybody else does. So yes, I know what Borat is. Although I haven't watched it. I have no desire to watch the most recent movie. Okay. All right, let's move on. So the most important thing for going forward is these two numbers right here you're going to need. All right, so I'm just going to quickly do 3 examples for you, okay? What's the probability that less than 4%, all right, in the sample work more than one job? Okay. So look, this is a less than question, okay? So it's probability that your p hat is less than 0.04. All right, so I'm just gonna do this without sketching it, just so you can see, like, instead of maybe the sketches are weird, like the key words, okay? So whenever you have a less than, you're still gonna do the normal CDF, but the less than tells me that my lower needs to be negative 99999. Okay, always. So when you see the less than, the lower is negative 99999. In my upper is this value right here. So it's 0.04, comma. And then the mean is 0.05. And the standard deviation is this, 0.0116. Okay. So look, you can do the sketch or not, but whenever you have a less than, this goes in the lower, always, always, always. So just grab your trusty calculator. Second function distribution, normal CDF, -9999, comma, 0.04, comma, 0.05, comma, 0.0116. I had an extra zero there, but it doesn't matter. How many people got this right here in their calculator? Valesky did. Anybody else? Okay, great. So it's 0.1943. Excuse me. Do you guys, I'm just curious, do you all think that the sketches help, or do you like this keyword stuff better? Okay. You can do either. All right, I'll do both in the next one just so you can see, okay? Question number 3. All right, what's the probability that more than 6.5% work more than one job? Okay. So whenever you see a more than, okay, all right, that tells me that the upper is going to be equal to 99999. Always, 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 always. So this is the probability that p hat is greater than 0.065, because I just got to change this to a decimal. So like, again, you can sketch it, right? So it's normally distributed. It should be centered at 0.05. And I want to be more than 0.65. So it's an area to the right. So it's normal CDF. What's my lower here? Yep, right there. Boom. And then my upper is going to be 99999. Mean is 0.05. Standard deviation doesn't change. So normal CDF, 0.065, comma, 9999, comma, 0.05, comma, 0.0116. How many people got this? 0.09. Okay, good. So when I round this to 4 decimal places, it's actually going to be 0.0980.
You can't just put the 6.5% as lower?
No, you cannot. You have to change it to a decimal. You have to. It's like, watch what happens if you just point. Yeah, like if you just go like.
I turned it to 0. I did it. That's why I was asking.
Say that again?
It just went to 0.
Yeah, it's just going to be 0. Yeah. So you have to make sure everything is a decimal. All right, last question for this. What's the probability that between, let's say, 3.5% and 5.25%, all right, work more than one job? Okay. Okay, so the key word here is whenever you see the between, okay, there's going to be no 999 stuff. Okay, this number is going to be my lower, and this number here will be my upper now. Okay. So less than, you're going to get the negative 999 for the lower. More than, the upper is going to be positive 99999. I'll get there, Leonardo. And then between is just going to be these two numbers. So it's the probability. Just have to make sure to change these 0, 3, 5, less than p hat, less than 0.0525, just to change it to a decimal. So then it's going to be normal CDF. 0.35 to 0.0525. And then notice the mean and standard deviation never changes. So 0.035, comma, 0.0525, comma, 0.05, comma, 0.0116. Leonardo had it right there, 0.4873. All right, what do you guys think? What do you all think? Not too bad? You think you'll be able to handle this? Good? Okay. So any questions before we take our break? He's good. It's good going through a little bit of a sleep regression. So I'm getting up a lot at night, but he's good. Thank you for asking.
Would you be able to leave the slide that
Yeah.
was did on?
Yeah, of course.
Yeah, thank you.
Is it okay if it's like this? Can you see it well enough?
Yeah, that's perfect.
All right.
I'm just writing down some notes.
Thanks for asking, Gillespie. Yeah, he's with the mother-in-law today. Well, the mother-in-law comes here and she helps us out, which is amazing. Hope everybody gets good in-laws if you ever decide to get married. I got lucky and got good in-laws. All right, I'll be back at 2. I'm going to go check on the little guy. Any other last-minute questions? Okay, enjoy your break. And then when we come back from the break, I'll spend 45, 50 minutes just doing a review for you for the exam. Okay? I'll see everybody at 2. All right, everybody. Shall we talk about the exam now with the time we have left? Okay. All right, so I really want everyone to do great on this exam. Okay, so there's going to be no surprises on the exam. Okay, and if you trust me, if you just stick with your calculator, okay, like I've been doing with that normal CDF, okay, excuse me, this should be for the most part an incredibly manageable. I don't want to say easy, an incredibly manageable exam for you. Okay, so Thursday when we come to class, please take a look at the posted homework, okay, in the classroom. So it's posted here, homework number 5. If please take 20 minutes, all right, before class on Thursday and look it over. If you have any trouble with it, I will start class on Thursday with questions. Otherwise, I'm literally going to move into a new topic on Thursday that will not be covered on the exam, but it will be on your exam number 4. Okay, so here are the topics of the exam for you. Okay, so the overarching concept of all these problems we've been doing are continuous random variables. But you'll have questions on a uniform distribution. So it's been a while since we've done that. So I'm going to go back and do that one. Normal distribution, which should be, these type of problems, you're just still going to use the normal CDF. Sampling distribution of the sample mean, still going to be a normal CDF question. And then this sampling distribution of sample proportion is what we did today. Okay. Again, just a normal CDF stuff. Okay, so there's no surprises in any of that. I'm going to do a quick review of these 3 topics. Okay, this one right here we just did, so I'm not going to do a review of it. Okay. All right, let's start with the uniform distribution. Okay, but before I do that, does anybody have any questions on this stuff? Okay. So uniform distribution. Your first question on your homework is this, and it's been a while since we've done these, okay? So this is what the problem will look like. The daily temperature in an industrial freezer follows a uniform distribution. And let me put some little context behind this, okay? I'm just making these numbers up, but suppose, there's this plant and it has to keep stuff below and temperature below freezing. And so the temperature in the freezer fluctuates throughout the day, right? So for whatever reason, right? Like they're opening and closing the door a bunch. There's so much in there that it's hard to keep the temperature constant. So for whatever reason, the daily temperature inside this industrial freezer isn't constant, and it follows a uniform distribution, okay, with temperatures between, let's say, 20 degrees Fahrenheit and 30 degrees Fahrenheit, okay? So I'm going to just ask you 3 questions from this, all right? Here's the first one. What is the probability density function? for the daily temperature in the freezer? Do you guys remember, I know it seems like it's been forever, but this concept of a PDF probability density function, does at least those words ring a bell? Yeah, you're being honest, that's fine. Okay. So here's the way it works. When I open up the door to the freezer, I don't know what temperature it's going to be. Okay, so I'm going to start by defining a variable. All right, I'm going to let X be equal to the temperature in the freezer at any given time. All right, what did I say the lowest temperature can be? Be 20 degrees. What did I say the highest temperature in the freezer would be? Yeah, okay. So this is what I'm saying. The value of X is always going to be between 20 and 30, okay? So when we're doing the PDF for this, I don't know if you guys remember, this was the A and B value, the starting and ending value. So the probability density function just goes like this. It was this piecewise defined function. Does this start to look a little bit easier? And it was 1 over B minus A. So 1 over 30 minus 20, which is 10. Yep, see, now you guys are starting to remember. And this is for 20 less than or equal to X less than or equal to 30. And does anybody remember what it's equal to otherwise? Yep, see, it's starting to come back. Yep. Perfect, okay. 2, let's sketch the density curve. For the variable X, for the random variable X. So if you remember, you draw the first quadrant of the Cartesian plane. And it's real simple. Here's 0. Here's where 20 is. Here's where 30 is. And then you take this 1/10 and you put it along the vertical axis. And then it was just like a straight line between them. And it's 0 otherwise. And that was it. Okay. Is that coming back to you all?
Just a little bit.
Okay. So now I'm going to ask you a probability question. Okay. What's the probability the temperature in the freezer is, let's say, is below 23 degrees? Okay. So it's the probability that that temperature, X, is less than 23. So if you remember, the way we did this problem was we shaded in the area under the curve. So 23 is going to be right here. And what did I say the lowest temperature in the fridge could be again? Yep. So I'm asking you if it's going to be less than 23. It's the same thing as between 20 and 23. So you have to find the area of this rectangle. Okay. So this probability is equal to area of rectangle, which is the length. So the length to go from 20 to 23 is 3. And the width is 1/10. So this is 3 times 1/10, or 3/10, or 0.30. Okay. So you're going to have a question like this on your homework. It's actually question number 1 on your homework. And the only thing that can be different, okay, is the numbers, right? Like everything else is going to stay exactly the same. Like the PDF is still going to be a rectangle, or the probability density function, excuse me, is going to be still this piecewise defined function. And the density curve is just going to be this flat line, okay? So I have some good news, okay? This will actually only be covered on your homework. Okay, I'm not going to actually even ask you something like this on the exam. Okay, so I just wanted to do this for you real quickly on your homework, all right? So do you think you'll be able to tackle the homework question? Okay. All right. Let's do another one.
Very nice.
Oh my God. Is that you, Leonardo, who's doing that?
Nah, I just came back.
Okay. Don't do the barrage. Okay. I know it's tough. We're all getting towards the end of the semester and we just want it to be over, but there's no need to.
No, we're just trying to make it fun. That's all.
Oh no, I'm just kidding. It is very fun. You know, doesn't everyone think, isn't statistics like one of the more fun classes you could take?
Yeah, it's just a little tough when you're doing 2 maths. That's all.
Everyone should be in the chat. You know, you should be even lying to me saying yes. Statistics is very riveting on its own. Actually, I'll be honest with you. Some of these topics here are a little dry, actually, but the final 2 topics of the class I think are the most interesting. So we're going to end on a high note. All right. All right, so let's, this stuff here goes back to like a few weeks ago, and these are the very, very simple problems. They have nothing to do with the sampling distribution, okay? So here's the problem. According to the US Energy Information Agency, which is a real agency. I'm not making this stuff up, this next stuff here, okay? The mean monthly electric bill in the United States is $110.14, okay? Let's assume that monthly electric bill is normally distributed with a standard deviation, excuse me, of, let's do $25.75, okay? So look, here's how this problem is going to go, all right? I'm going to tell you something is normally distributed. I'm going to give you a mean and a standard deviation, and I'm going to ask you a probability question. So if a monthly electric bill is selected at random, okay, what's the probability it is less than $81.23? Okay, the reason I picked $81.23 is that was my electric bill last month, okay? You're getting a little extra piece of information about my personal life there.
I wish that was my electric bill.
It's always higher in the winter, okay? But it's, you know, the weather's been decent here. We haven't actually had to run the AC much or the heater much. So
No, mine's usually high all year round.
I'm sorry to hear that, you know.
No, it's okay. I mean, I split it with my brother, so it's not too bad.
And we got a little piece of information into his personal life there. So that was good.
Yep, trying to get a little personal here.
Oh, the things that are said over Zoom. Okay. So this right here, this problem here has nothing to do with the sampling distribution. Okay, so I'm going to define a variable. Okay, so, you know, before I select the monthly electric bill, I don't know how much it's going to be. So I'm going to define the variable. I'm going to let X be the amount of a randomly selected monthly electric bill. Okay. And I want to find the probability that that X is less than 8123, $81.23. Okay. Couple, you know, what do you guys think, just out of curiosity, might help you to prevent you from making an error? Like, what do you think you could do next to help you? Yeah, sketch. So if you're like unsure what to do, like the sketch is never a wrong answer. Okay. So what I'm going to do here is I'm going to sketch the distribution of monthly electric bills. And look, here's what I know. I know it's normally distributed. I know what its mean is. And I know what its standard deviation is right there. So it follows the bell curve. Centered at 110.14. And I want to be less than 81.23. So 81.23 is over here. And I'm going to shade to the left. Okay. To answer this question, what do you think I should use? So you could totally do it by hand. Okay, you could totally do it by hand and use z-scores. I recommend not doing that. Okay, what will help us solve this? Like what have we been using all class for the last hour and 20 minutes? Yeah, the normal CDF. Okay, I'm gonna give you a hint. Okay, a hint for the exam. Whenever, so just pay attention to this. Like, okay, so if you're lost on the exam, like what should I do? Any question that asks you a probability on the exam, like find the probability of this, you should use the normal CDF. Okay, always, always, always. So normal CDF. So what goes in the lower here as a left-tailed test here, or left-tailed probability, excuse me. Yep, negative 99999, comma. What's my upper value here? Yep, you want to find all the way up to 81.23. And then the mean, look, I give you the mean, it's 110.14. And the standard deviation is 25.75. Grab your calculator. Normal CDF, negative 9999, comma, 81.23, comma, 1110.14, comma, 25.75. Did anybody follow along and get this? So it's 0.1308 when you round it. Okay. So always use the normal CDF here. Okay, always, always, always. I'm going to do one more of these, okay? Sticking with this monthly electric bill problem. Is everybody okay if I move on or need a second? So here's the next problem. All right. If a monthly electric bill is selected at random, all right, what's the probability the bill is between, let's say, $100 and $150? Okay, so like when you look back here, I said this was a less than, so it told me like how to set it up with the negative 99999. What's the keyword like in here that's telling me how to set it up?
When it says between, there's not going to be, okay, the class already went ham on it.
Yeah, whenever there's the word between, you guys are right. I don't need the 999 stuff. So it's the probability that that electric bill is between 100 and 150. Okay, if it helps, you can still sketch it. The mean was $110.14. And I want to be between 100 is over here. 150 is probably way over here. I want to find this area between here. All right, so it's normal CDF. You do not have to sketch it. Nope, nope. There'll be no area on your exam for you to sketch it. I'm only interested in the answer. So I just only sketch if you need it. So the lower here is this 100. The upper is 150. The mean is 110.14. And I think I said the standard deviation was 25.75. So normal CDF, 100, comma 150, comma 110.14, comma 25.75. How many people got that answer on my calculator right there? So 0.5923.
I did.
Okay. I think you'll be able to handle and answer a question like this. Okay. Yeah. All right. So basically, you're going to get two questions that look like this on there. Okay. Multiple parts. Like, let me rephrase that. You'll get your exam will be like 20 questions total. And you'll get like 6 or 7 questions that are just like this. Like, well, you know, if the mean is this, the standard deviation is this, what's the probability it's between this and this? Okay. All right, any questions on this before I move on to the sampling distribution of the sample mean? No questions? Okay. All right, so now we're talking about the sampling distribution of the sample mean. All right, so the problem might look like something like this. A Nielsen company report has anyone heard of Nielsen company, Nielsen and Co? Just out of curiosity. So what they do is they track like how they track everything related to television. Like they're the big company that, you know, tells you like how many people watch the Super Bowl, how many hours are people spend watching TV, stuff like that. So anyways, they had this report that came out. A Nielsen company report states that the mean number of televisions per household is, so on average, households have 2.24 televisions in them. Obviously, you can't have 0.24 of a TV, but that's just the average of everybody. Okay. I'm just curious, what do people think of that? Low, high?
Very high.
Oh my God. So it's weird, right? Like some households, I have some friends who have, you know, like 5 TVs in their house. You know, but my wife and I, we only have one TV. Like we have like a TV room and that's it.
Now we know why the electric bill's so low.
There you go. That's why my electric bill's so low. And then trust me, when you have a child, you'll find that you don't have any time to watch TV. So I'm behind on all my television shows, except for The Mandalorian. You always got to make sure to watch that every week. Okay, on Disney Plus. Anyways, Nielsen reports that the mean number of televisions per household is 2.24. And let's assume the standard deviation for households per TV, or for televisions, televisions per household, excuse me, households per TV, for TVs per household is 1.2. Okay. Next is going to say something like this. A sample of 75 households is taken. And the sample mean is calculated. Okay. All right, do you notice in here, there is nothing that says normally distributed in the problem? Do you see that? There's like nothing that says that the number of televisions per household is normally distributed, okay? So the reality is the number of households per TV, number of TVs per household is not normally distributed. It's like way right skewed. But that doesn't matter, okay? So the first question, or the first thing I'm gonna look at is, so I'm gonna sample 75 households and compute the sample mean. So I'm gonna define this variable. I'm gonna let X bar equal to the mean number of TVs per household in a sample of 75 households. Okay. Does anybody remember what I said the most important theorem of the class is?
The central limit.
That's right, the central limit theorem. And basically the central limit theorem says the following. As long as does anybody remember what it said the sample size had to be greater than or equal to?
Was it 30?
That's it, you guys got it. See, you guys remember, yep. So as long as the sample size is greater than or equal to 30, which it is, we know the sampling distribution of X bar will be normally distributed. So even though it doesn't explicitly say it, that's okay. So the next part will be something like this. Because the sample size is greater than 30, the sampling distribution of X bar will be normally distributed with, so you just got to say what the mean and standard deviation is. Okay, so the mean, we denote this as mu sub X bar. Okay. Does anybody remember what that's equal to? What the formula was? Well, it turns out that it's equal to whatever the population mean is. Okay. And look here. This right here is the population mean. Okay, you're given that mu is 2.24. Now the standard deviation is a little different. Does anybody remember the formula for that? A lot of crickets. That's okay. That's why we do review. Yep. Pi of n, I think you mean like the square root of n. Yeah. So you take the population standard deviation and you divide it by the square root of the sample size. Okay. So look, you're given the standard deviation, it's 1.2, and you divide it by the square root of the sample size, which is 75. So 1.2 divided by the square root of 75, you should get this. Okay. How many decimal places do you need to take this out again? Yeah, you need 4. You need 4. So 0.1386 when I round this. Okay. So I see some people kind of like, we did this last week. Does it somewhat ring a bell? Like kind of comes back? Yeah, it's okay. It's easy to forget this stuff. I get it. A lot going on in the world. I feel like last week was a crazy week anyways. Okay, so listen to me. If you're going to tackle this problem exactly, the probability questions exactly like we did in this previous problem and this one too. The only difference is whenever I give you a sample size and ask about a sample mean, like computationally, the only thing you have to make sure to do is take the standard deviation and divide it by the square root of the sample size. Okay. And then you're going to take this value and plug it into the graphing calculator. All right, so now is everybody okay if I go to the next slide and ask some probability questions?
Wait, what are you going to do with the 2.24?
You're going to see. You're going to see. That's going to still always be the mean, like the mean. It's going to stay in your graphing calculator.
All right.
Everybody okay if I go to the next slide? Okay. So I might ask a question like this. What's the probability the sample mean is, let's say, greater than 2.4 TVs per household? Okay. So it's the probability that X bar now is greater than 2.4. All Okay, so if it helps to see it, you can sketch this, okay? So what I'm going to do is I'm going to sketch the distribution of X bar. Well, if you look back here, it's normally distributed, centered around 2.24. And I want to be greater than just 2.4. Yeah, come on. All right, so I've drawn the normal curve. I've shaded in some area. What do you think you do next? What's the easiest way to solve this?
Write out your lower, your upper, your mean, and your standard deviation.
Yep. Use your normal CDF. Okay. The lower here is 2.4. So this is a right-tailed probability. So what's my upper?
9.
Okay. This right here are the mean and standard deviations you're going to plug in now. Okay, so 2.24, comma 0.1386.
You're not keeping the original standard deviation?
You do not. Whenever I ask you a question that involves a sample mean, okay, the probability of sample mean, you have to use this. You have to use this sigma X bar. Okay, you have to. All right. If students get the question wrong 9 times out of 10, it's just because they use 1.2. Okay, so don't make that mistake. So then grab your calculator, normal CDF, 2.4, comma 9999, comma 2.24, comma 0.1386. How many people get this? 0.1242 when I round it. Looks good? What noise are you hearing?
It's like a printer. I don't know. Something's printing.
Yeah, in my house, but it stopped, right?
It just stopped.
No, it's still there. I was wondering if something was wrong with my computer.
No, does it actually sound like a fan that's kind of going?
No, it sounds like a printer.
Sounds like an old microphone. Let's see. I bought a new one. Let's see. Well, we're almost done. Okay. Sorry, that must be me. You guys can still hear it now? Okay. All right. Well, my computer was actually just overheating, so my fan kicked on in my desktop computer, so maybe that's what you were hearing. Who knows? Or it's a phantom printer. Okay. All right, how about one last quick question and then we'll call it for today, okay?
Yes, sir.
So sticking with the same problem, all right?
Does that cover all the topics?
Yep. What's the probability the sample mean is less than two televisions per household? Okay. So in this case, it's the probability that my X bar is less than 2. So it should be 2.24. That's the mean. And I want to be less than 2. So I'm going to shade to the left. So it's normal CDF. Since it's a less than, what's my left? What is my lower value here?
-999.
Yep. And you're going to go up to 2. You're going to be 2.24 is the mean, and that's 0.1386 is the standard deviation. So grab the calculator. Normal CDF, -9999, comma 2, comma 2.24, comma 0.1386. And then how many people got this? Yep, 0.0417. Good. This is all on the homework, yep. So let me just. Okay, so this is what your exam is on, okay? If you do the homework this week, homework number 5, come to class on Thursday with questions. I promise you, you'll do well on the exam. Okay. All right, what a class. Does anybody have any last minute questions?
What was the test again?
Next Tuesday.
Oh, okay.
Yep. So on Thursday, we're going to do a brand new topic, but that topic is not covered on the exam. I'm just giving you a full week to study for the exam and do the homework. All right. All right, everybody. Thanks for a great class. I will, I'll email you all as soon as the recording is up. Okay?
I have a question.
Sure.
For the next PowerPoint, if you are you able to put it up as a PDF?
Are you not able to open up PowerPoints?
They do open up, but some of the slides are empty.
Oh, you don't see my writing. Is that what you're saying? I don't understand. What
Before
do
the
you mean?
write-up, yeah.
So when you open up yours, you don't see my red writing?
No, I see the red writing, but I don't see the things that are typed.
Yeah, so professor, so yeah, it'll show up like a screen like that. You see, if you go back to the exam, go back to the last slide.
This?
So sometimes when we're scrolling through the slides, it'll have a page that's like this. It'll be like page number 9, and then it'll show all gray screen with not one writing on it.
Huh. Okay.
Now you understand?
Yeah, I'm sorry. I didn't realize that happened. Yeah, so what I'll do is I'll just save this as a PDF then and post it as a PDF. Sound good?
Yeah.
Okay, yeah, thanks for pointing that out. I had no idea. So now you'll be able to open it up like this. Okay, and you should see everything. Sorry about that. I'll just do that going forward for you all, okay? All right, I will see you guys on Thursday.
Have a very nice day.
Okay, all right. All right, goodbye, everybody.